Download this code from codegive.com, link in the description below. Adding new features to a legacy code base, a comprehensive guide. Adding new features to a legacy code base can feel like walking through a minefield. It's often riddled with outdated practices, undocumented logic, and tangled dependencies. However, with a strategic approach, you can successfully introduce new functionalities while minimizing the risk of destabilizing the existing system. This tutorial will delve into the intricacies of this process, providing guidance, best practices, and code examples. What is legacy code? Legacy code is code that has been in production for a significant period and is often poorly documented, lack of comments, outdated documentation, and a scarcity of technical specifications. Complex and entangled, high coupling between modules, deeply nested logic, and convoluted control flow. Lacking tests, insufficient or no automated tests, making refactoring risky. Uses outdated technology, relies on older libraries, frameworks, or languages. Difficult to understand, obscure variable names, inconsistent coding styles, and unfamiliar design patterns. Business critical, often essential for core business operations, meaning changes can have significant impact. Challenges of working with legacy code. Fear of introducing bugs, lack of understanding and test coverage increases the chance of breaking existing functionality. Slow development speed, untangling the code and understanding its behavior consumes significant time. Maintainability issues, the complexity makes it hard to adapt to new requirements and keep the system running smoothly. Technical debt accumulation, quick fixes and hacks applied over time contribute to the overall technical debt. Resistance to change, teams can be reluctant to modify a system they fear to break. Strategic approach, the strangler fig pattern. The strangler fig pattern is a powerful strategy for incrementally replacing legacy systems. It involves wrapping the old system with a new facade, gradually adding new features to the facade, and slowly migrating functionality from the old system to the new one. This allows you to introduce new functionality without a risky big bang rewrite. Here's how it translates to adding features. 1. Identify the scope. Define the new feature precisely. Clearly understand the requirements and the desired outcome. Document everything. Determine the impact zone. Identify the modules or components of the legacy system that will be affected by the new feature. This is often the most difficult part. 2. Characterization tests, golden master tests. Write tests to understand the existing behavior. Before making any changes, create tests that capture the current functionality. These tests are crucial for ensuring that your changes don't break anything. Golden master approach. Capture the exact output of the legacy system for specific inputs. Compare the output of your changes to the golden master to verify correctness. Example, Python. Key. Don't worry about why the legacy code behaves a certain way at this point. Focus on what it does. These tests must pass before you modify anything. 3. Create a seam. Introduce a seam in the code where you can inject your new functionality. This often involves creating an interface or abstract class. Avoid direct modification. Try to avoid modifying the core legacy code directly if possible. Favor extension over modification, open/closed principle. Example, Python. Suppose legacy processor is hard-coded to use a specific calculation method. We can create a seam by injecting the calculation method. 4. Implement the new feature, behind the seam. Asterisk write the new functionality using modern practices. Asterisk follow solid principles, write unit tests, and ensure the code is well documented. Asterisk keep it separate. Asterisk ideally, the new feature should be developed in its own module or class, distinct from the legacy code. Asterisk example, Python. 5. Integrate the new feature. Asterisk use the seam to connect the new feature to the legacy system. Asterisk pass the necessary data to the new feature and integrate its output into the existing workflow. Asterisk feature flags / toggles. Asterisk use feature flags to enable or disable the new feature, allowing you to test it in production without affecting all users. This is a very powerful technique. Asterisk example, Python. 6. Monitor and test, extensively. Asterisk production monitoring. Asterisk monitor the system closely after deploying the new feature. Track performance metrics, error rates, and user feedback. Asterisk A/B testing. Asterisk if possible, use A/B testing to compare the performance of the new feature against the old functionality. Asterisk regression testing. Asterisk run your characterization tests and integration tests to ensure that the new feature has not broken any existing functionality. Asterisk non-functional testing. Asterisk consider performance, security, and accessibility testing depending on the feature's impact. 7. Refactor gradually. Asterisk identify areas for improvement. Asterisk as you gain a better understanding of the legacy code, look for opportunities to refactor it. Asterisk small, incremental changes. Asterisk refactor in small, testable steps. Run your characterization tests after each change to ensure that you have not introduced any regressions. Asterisk move functionality to the new code. Asterisk gradually move functionality from the legacy system to the new, more maintainable code. Eventually, you can remove the legacy code entirely. Code examples and explanation. Asterisk extract method refactoring. Asterisk explanation. Asterisk we extracted the calculation of the order total and the application of discounts into separate, well-named functions. This makes the code more readable and easier to test. Make sure you add characterization tests before you extract. Asterisk replace conditional with polymorphism. Asterisk explanation. Asterisk we replace the conditional logic with a hierarchy of tax calculator classes. Each class is responsible for calculating the tax for a specific product type. This makes the code more extensible and easier to maintain. You can easily add new product types without modifying the existing code. Again, characterization tests are crucial before this type of refactoring. Key considerations and best practices. Asterisk communication is key. Asterisk talk to the people who know the system best. Ask questions and document everything. Asterisk version control. Asterisk use a version control system, example Git, to track your changes. Create branches for new features and merge them carefully. Asterisk automated builds. Asterisk set up automated builds and testing to ensure that the system is always in a working state. Asterisk continuous integration. CI integrate your code frequently and run automated tests to catch errors early. Asterisk code reviews. Asterisk have your code reviewed by other developers to catch potential problems. Asterisk small steps. Asterisk break down large tasks into smaller, more manageable steps. Asterisk test-driven development, TDD. Write tests before you write the code. This can help you understand the requirements and avoid introducing bugs. Even if you can't fully embrace TDD due to time constraints, writing tests for your new feature code is still crucial. Asterisk documentation. Asterisk document everything. Write comments, update existing documentation, and create new documentation as needed. Tools like Sphinx or Doxygen can help with generating documentation from code comments. Tools use tools to help you understand the code. Debuggers, profilers, and static analysis tools can help you identify problems. Consider using code analysis tools like SonarQube or Code Climate to identify code quality issues. Patience. Working with legacy code can be frustrating. Be patient and persistent. Don't rewrite from scratch. Generally, rewriting from scratch is almost always a bad idea. It's a huge undertaking, and it's likely to introduce new bugs. The strangler fig pattern is a much safer and more effective approach. Dependency injection. Leverage dependency injection to decouple components and make the code more testable. Design patterns. Familiarize yourself with common design patterns, example strategy, factory, observer, and use them to improve the design of the code. Understand the business domain. Understanding the underlying business logic is critical for making informed decisions about how to modify the code. Example scenario: adding email notifications to a legacy e-commerce system. Let's imagine you need to add email notifications to an older e-commerce system written in PHP. The system doesn't have any email functionality and is quite monolithic. 1. Identify the scope. New feature. Send an email notification when an order is placed. Impact zone. The order processing module, database access layer, and potentially the user management module. 2. Characterization tests. Write tests that verify the existing order processing logic. This might involve creating a dummy order and asserting that it is correctly saved to the database. Since there's no email functionality yet, the tests won't cover that. But they ensure that you don't break the existing order processing. 3. Create a seam. Introduce an interface. Define an email service interface with a send email method. 4. Implement the new feature. Create a concrete email service implementation. Use a modern library like Swift Mailer or PHP Mailer. 5. Integrate the new feature. Modify the order processing module. After an order is successfully processed, inject the email service, example using constructor injection if possible, or using a global service locator if the system is truly old. Then, call the send email method. 6. Monitor and test. Test the email sending. Create a test environment and verify that emails are sent correctly. Monitor the system. Check the logs for any errors related to email sending. Consider using a mock email service. For unit tests, create a mock implementation of the email service that doesn't actually send emails, allowing you to verify that the send email method is called with the correct parameters. 7. Refactor gradually. Improve the email service implementation. Add features like email templates, queuing, and error handling. Decouple the order processing module. Further. Use events or messaging to decouple the order processing module from the email notification logic. This makes the system more flexible and easier to maintain. Conclusion. Adding new features to a legacy codebase requires a methodical and patient approach. By using the strangler fig pattern, creating seams, writing characterization tests, and refactoring gradually, you can successfully introduce new functionalities while minimizing the risk of destabilizing the existing system. Remember to prioritize communication, documentation, and automated testing to ensure a smooth and successful integration. Good luck.